All right, so I want to go through this problem right here. Class, we have seen this before. If you look at this, it talks about a table showing the maximum daily temperatures in degrees Fahrenheit for Tallahassee and Chicago. And then the question here, the task is to find a trigonometric model for the temperature in Tallahassee. So we're not really even concerned about Chicago. We're only concerned about Tallahassee and the month. And when you find the trigonometric model, the first thing you should do is to begin to, in your mind or on paper, create a basic plot of what your x-axis is going to look like and what your y-axis is going to look like. When we look at this problem, the x-axis is going to be the months of the year. So contrary to what things have been like in this class, now our x-axis is not necessarily an angle in radian measurement. In this case, it's going to be the month, and the y-axis represents the temperature in degrees Fahrenheit. So what I did was, you'll see on the screen right here, a basic plot where I gave you the 6-month and the 12-month interval right there, and I gave you the two temperatures. And if you'll look, here's the basic outline of what this graph looks like, just simply from the data right here. We have a low point at month 1, we have a high point at month 7, and then we have a low point again at month 12, and we know it's trigonometric, so it's going to create a wave. Now, these waves don't stop. This is just one cycle of the wave. And you're told to find the trigonometric model. And like I told you before, when you're given data, the best thing to do is to go into your calculator and to do it. So I have right here this stuff already queued up in my calculator. I'm going to pull it over here to cover the screen. That's all right. If you go into press your stat and enter, type in all of your numbers. I use list 1 and list 2. Make sure you type them in correctly and that you correspond them. In other words, 1 has to correspond to 63.9, 2 to 67.1, etc., just like that. And then if we want to create the model, all we need to do is go to Stat, over to Calc, and then scroll up or down, whichever your calculator will let you do it, and find SINREG. That's the sine regression. That's a best fit model for the trigonometric modeling that we're going to do. And then, of course, enter. Now, your screen may not look like mine, but the bottom line is you need to tell this calculator to pull all of your independent or your x values from the list you put your x's in and pull your y values from the list you put your y's in. Mine asks for the period, and my period is 12, and the reason it's 12 is if you look at the data over here, and I'm circling again, and if you look at the graph goes through one complete cycle in 12 months. So I know that my period is 12. All right, and then it says to store the equation and calculate. I've already done that. So if you calculate it, notice that you get your numbers right there. But also notice that this is the form of y is equal to a sine of bx plus c plus d. And it gives you a, b, c, and d. And of course, you can put those in your calculator straight like they are. You can pull them in, or, actually, I'll show you how to pull them in. You can go to y equals. Those of y'all who didn't get that before, go down to an empty y equals part of things. If you just want to pull the equation in, you'll hit the bars button, which is beside the clear, and go down to number 5, and enter, and then go over to EQ, and enter, and it will pull in the last regression equation you did. It'll pull it in, all right? Now, so it's in Y3, but I don't want it in there, so I am just going to go ahead and clear that. And what I did was in Y1, I rewrote that equation rounding to 3 decimal places. Is in Y1 up there. That's the equation that the calculator gave me, and I rounded all my numbers to 3 decimal places. And that is also written right here. So what I just circled in blue is the answer that you need if you just simply want to find a trigonometric model using the data and putting it into the calculator. And just to show you, we can go back to the calculator, and if you hit second, y equals, enter, and make sure your first plot is on, and you can look at what I have up here. We want the scatter plot, which is the first type. Make sure you put in your correct x and y list, all right? And then if I go to my y equals, you will notice that y1, the equal sign is highlighted. y2 is not. That's one we're about to find by hand. I purposely have that turned off. And then just hit zoom 9. And you'll notice there are the dots, and that blue line graphing it is the model of best fit. Right? That's what your calculator gives you. So from that, we could go into y equals if we wanted to. We could, or excuse me, go to the window, second window, told y'all wrong. Go to the ask function and hit second graph. Right? And I'm going to hit delete, just clear everything out. Let's say that I want you to predict the temperature for month 15. And you would just type in 15 and enter. What that did was that put 15 into that y equals equation for x, and you would predict in the month 15 the average temperature would be 65.459. Just like that. Okay? Now, that's using the calculator. But another method we looked at was doing this by hand. That was the other method we looked at. And doing it by hand, the reason we want to even consider that is that sometimes you're not given all the data. Sometimes it's not so easy to find all these things. And you can't just go put stuff in your calculator. And what you don't want to do is put things in your calculator where you only have like 2 or 3 data points. You don't want to do that because then your calculator runs a bad risk of being way off. So it's not necessarily a bad thing to do this by hand. So here's the same data right here. The same data, and again, we're not concerned about Chicago at all. We're only concerned about Tallahassee. And we've already drawn the graph on there. That came from, so we know basically what the graph should look like on there. So if we're doing this by hand, remember our equation looked like this. It was y is equal to a times the sine of bx minus c plus d. Remember in the calculator it was bx plus c plus d. We use minus c. That's just the way the format is in the book. So here's what we want to do. To get our equation, we want to find a, we want to find b, we want to find c, and we want to find d. And once we have that, we have our equation. All right? Well, remember, A is our amplitude. If we were to draw this graph right here, this graph is bisected by what we call a median line. That's a line that just sort of goes halfway through the graph. And the amplitude is the distance from that median line to the top point or that median line to the lowest point. Either way you want to look at it, that's what the amplitude is. And the formula for amplitude, if you will remember, was the highest y value, which is 91.3, minus the lowest y value, 63.9, and then you divide that by 2. And you should get 13.7. You can do that in your calculator. In fact, I'll go ahead and pull this one up and do it that way. Calculator will work here. So it's 91.3 plus, sorry, not plus, minus 63.9. And then you want to divide that by 2. So our amplitude is 13.7, just showing that to you on the calculator. And again, what that means is that you're 13.7 units above a median line and 13.7 units below a median line. That's what the amplitude gives you. Now, compare 13.7 with this amplitude in this equation. They're a little bit different, but that's okay. Doing it by hand will not give you the exact number, but it gives it to you close enough. So that's the amplitude. And we figured out, and I'm going to switch these around, we figured out that it's easiest to find D next. D represents a vertical shift. And the reason we want to find a D next, D takes into account how far up that median line has shifted. That's what D takes into account. How far up, let me label these A, and D. D takes into account how far up that median line is shifted. With no shifts, the median line is the x-axis. What we've done is D tells us how far up it's shifted. And the method we use is we simply want to find what is the midpoint between the top and the bottom number of y. In other words, what's the midpoint between 91.3 and 63.9? And there are several ways you can do it, but the easiest way is to use the midpoint formula. So it's this y plus this y divided by 2. and that gives you 77.6. I'm not going to do that in the calculator. You can do that in the calculator. It does work. And the reason I do A and D first is that there is only one difference in how you do it. In A, you subtract the two top numbers, and D, you add them. Everything else works out the same. So if we're creating our equation, then to begin with, here's what we have. I want to erase B and C for a second. Here's what we have. We have y is equal to, A is 13.7 times the sine of bx minus c plus 77.6. That's our equation so far. Now the only thing we need to find next is B and C. It's B and C. Well, B is not so hard. I'm going to just pull these down. Make it a little smaller and just pull it down. We found out from previous work, here's what we know. We know 2 pi over B is the period. Therefore, B is 2 pi over the period, just using algebra. And again, if you don't believe me, put a 1 under the period, cross multiply, right? Solve for the B part of things. That's what you're going to get. 2 pi over the period is equal to B. Now I'm going to erase this, so if you want to pause the video and copy that down, do that right now. Yeah, okay. Had a slight interruption there. So 2 pi over the period. We've already figured the period is 12. That comes from the graph. In other words, the distance of one complete cycle is 12 months. So therefore, our period is 12. So B is 2 pi over 12, which reduces down to pi over 6. Now you can put pi over 6 in decimal format if you desire, but that's not necessary. All right, so what I'm going to do is I'm going to erase this part and rewrite it. Sine of pi over 6x minus c plus 77.6. So now the only thing left to find is c. And algebraically, c is found by plugging in a number for x and a number for y and solving for c. Plugging in a number for x and a number for y and solving for c. You could put in any of these numbers for x and for y. You can do that. You will get a different number for c, but the end result for predictions will work out okay. However, as a matter of standard, what we generally do is pick the lowest the lowest y value and its corresponding x. That's really just a matter of standard. Pick the lowest y value and its corresponding x. So what we're going to do is plug in 63.9 for for y. I keep saying that wrong. For y, and 1 for x, because that comes from this table up here. That's the lowest y value and its corresponding x. And then we're going to solve. Now solving is done with this screen here. And you may want to pause your video and copy this down, but this is the method for solving, again, using the lowest y value and its corresponding x. We could have used any of those on the table, but the standard is to always use the lowest y value and its corresponding x and work it through, and c becomes 2.095. And again, you may want to pause your video and copy this down and go through the algebra, but the bottom line is this is how you can solve for c. Okay, you might have noticed a slight pause in here. All I was doing was we were on this screen, and I told you to pause the video and copy it down. And what I did was I took the c value and I rewrote it in the equation right there. Okay, and so we have y is equal to 13.7 sine pi over 6x minus 2.095 plus 77.6. And if we put that into our y equals, which I've already done, that's the second y equals up there. No, I cut off the first one, it's not up there. And if we graph it, it will closely model our data. Now, is it perfect? No, it's not. But it's close enough for what we want. And I will go ahead and put in here, go back to the y equals, and I will put both of those in now. And if you'll look, the blue one touches the dots closer. It does do that. So obviously the calculator model is the better one as far as touching the more dots, but the red one's pretty close. Again, it's not going to be perfect, but it's the best we can do with the data. And again, lastly, you go into the table, and now there is a difference of 5 degrees there. Again, doing it by hand will not get you a perfect one because you're limited in how you're getting the data. But it is a good way to do that. So this video was to show you how to work this out by hand, finding A, B, C, and D. And that is going to come in handy when we do some other word problems. So I hope you found this helpful. If you found